show that x equals 2i is a zero of this polynomial, and use that result to find all zeros of the polynomial. First, note that all the coefficients on this polynomial are real. So if x equals 2i is a zero, then its conjugate, x equals negative 2i, is also a zero. Rewording this in terms of factors, if x equals 2i is a zero, then x minus 2i is a factor. And if x equals negative 2i is a zero, then x plus 2i is a factor. Multiplying this out, we get x squared plus 4. So if x equals 2i is a zero, then x squared plus 4 must divide into this polynomial evenly. So let's test that by using long division. We take x squared plus 4 into our polynomial. X to the fourth minus 2x cubed plus 7x squared minus 8x plus 12. And we'll put the division bar on top. So we start out with our long division process. We have 3 steps: divide, multiply, and subtract. We divide the leading terms. X to the fourth divided by x squared is x squared. Next, we multiply. X squared times x squared plus 4 gives us x to the fourth plus 4x squared. And then we subtract. We subtract the row that we just found from the top row. X to the fourth subtract x to the fourth will cancel. There's nothing being subtracted from the negative 2x cubed, so that'll just come along down to the bottom row. 7x squared subtract 4x squared gives us 3x squared. And the last 2 terms, nothing is being subtracted from, so those we can just copy down to the bottom row as well. Then we go back to the front and divide again. Negative 2x cubed divided by x squared gives us negative 2x. Then we multiply. Negative 2x times x squared plus 4 is negative 2x cubed minus 8x. And then we subtract. So I see in the first column, the negative 2x cubed subtract negative 2x cubed will cancel. 3x squared, nothing is being subtracted from, so we can just copy that down to the next row. Negative 8x subtract negative 8x will cancel. And plus 12 will just carry down. We'll do one more division. 3x squared divided by x squared is 3. And then we multiply. 3 times x squared plus 4 gives us 3x squared plus 12. And then finally we subtract. 3x squared subtract 3x squared will cancel. 12 subtract 12 will cancel to give us a remainder of 0. Since the remainder is 0, that says that x squared plus 4 does divide into this evenly. So x equals 2i and x equals negative 2i are both zeros. Since they want us to find all the zeros, we need to keep going. We need to know when this quotient, x squared minus 2x plus 3, is 0. In theory, we can do this either by factoring or using the quadratic formula. I don't see a way to factor this, so I'm going to use the quadratic formula. This is x equals negative b plus or minus the square root of b squared minus 4ac. And this is all divided by 2a. Simplifying this, this gives us positive 2 plus or minus the square root of negative 8 all over 2. We can simplify that radical. The negative will come out of the radical as I, the imaginary unit. 8 we can break apart as 4 times 2. So that means a 2 will come out of the radical and a 2 is left on the inside. And then finally we can simplify this further by reducing fractions to 1 plus or minus I radical 2. And now to test to make sure we have all the zeros, this is a degree 4 polynomial, so we should have 4 zeros. X equals 2i was given. That's the one we verified with a long division. X equals negative 2i was its conjugate. We confirmed those were both zeros. And then we have x equals 1 plus I radical 2 and x equals 1 minus I radical 2. We found 4 zeros to a degree 4 polynomial, so we know we found all the zeros.